we dive into this. These are multi-step problems. Number one is specifically using the percent error equation that we mentioned earlier. You have to be careful here because remember, this 100% is considered to be an exact number. Exact numbers come from being able to physically count objects. So if I had 5 cookies, the number 5 would be exact, okay? It's sig figs, it doesn't have any, it has infinite. So we can't consider it when we're using sig figs to round off our answer. It comes from defined quantities, like a centimeter is 10 to the negative 2 meters. The number 1 in the power of 10 would be exact. It comes from numbers that are part of an equation before your data goes into it. So the 100%, which is part of percent error, is exact because of that very reason. Does this make sense? Okay, so when we go to do number 1, for example, we take the 9.825 minus 9.804. Obviously, both of these measurements go 3 places past the decimal, so you would draw your line here, okay? And then you're going to end up with 0.021. You're going to underline the 2 and the 1. We're not going to round anything yet, because not that there's anything really to round because there's nothing after the line, but now we're going to go on and do the next step, okay? So here I had 2 sig figs. I'm using that here, right? So I have 2 sig figs here. Technically you have 4 here. So that means after we divide and multiply by 100, we will use the term with the fewest sig figs, which is 2, to round off our final answer. Okay, so you're going to end up getting 0.21374. I'm going to underline the 2 and the 1. This would be 0.21%. That's 2 sig figs for your answer. Okay, but do not round until the very end. Just keep track of sig figs as you go. Do you want me to do one more with you, or do you want to try one on your own? Do you want me to do one more? Okay, number 2. Number 2, I'm going to do what is in parentheses here first. So I'm going to take the 424.4 plus the 42.8. Draw my line after those 2 because they both go to the tenths place. This is going to give me 467.2. Underline the 467.2 to remind you that this is how many sig figs you have from this operation. Technically, this is 4, okay? Then we're going to divide. So this is 804.08 grams divided by 467.2 milliliters, okay? So here we have 4 sig figs. Here I have 5. So since I'm dividing, the rule is you look for the fewest sig figs, which would be 4. Okay, and then you're going to write down this answer. So this is going to be 1.72106. I'm going to round this off to 1.721 grams per mil. Okay, you try number 3. Let's see what you come up with. I'm getting hungry. I got 1.7.
I got that too.
You did? Okay. And? Okay. Want me to walk you through it?
I rounded, but I still
Oh yeah. If you round at an intermediate step, you'll get something different. Yeah. Okay. Any questions? We're good? Okay. That's the end of this section. Okay. Do you need me to write down what exact numbers are, just so you have it as a reference, when I mentioned? Yeah? Okay. So let me write that down up here in blue. So exact numbers come from physically counting objects, defined quantities, typically quantities that are in the same unit of measurement. So if you're in the metric system, a centimeter equals 10 to the negative 2 meters. The number 1 and the power of 10 would both be exact. If you're in the English unit system, like 1 foot equals 12 inches, the number 1 and the number 12 would be exact. But when you go to compare two different systems of measurement, like metric to English, that's not necessarily exact. They would have to tell you that it was exact. And then for number 3, it would come from a number in an equation prior to your data being put in it. So like with the percent error equation, the 100% is already in that equation before you put your actual values inside of it. Okay? All right. So do you have any questions for me on this section? Nada. Okay. All right, I'm going to stop this video. These words will all come back.